Welcome everybody. Thank you for attending this webinar on ElectricalOM. I'm going to go through some of the bits and pieces we're going to do today. So let's get started with a little bit about what ElectricalOM is. ElectricalOM at its core is a calculation engine, and we use this calculation engine with ElectricalOM to produce various outputs such as schematic data, electrical design. We have analytics, which allows us to look at selectivity studies as well as arc flash. We have our integration with CAD principles, which allows us to work very well with programs like Rivet, as well as other external CAD programs. We have our mobile app, which is currently out on beta, so we can take a look at various systems, looking at EICRs. We can update existing schematics from that data, and we can also bring in information from historic properties where there may not be any historic data that we have there, in order to help produce various EICRs, as well as schematic data and historic design data for when it was installed. And then we have our certification and reporting. And of course, all this is done in compliance with the BS 7671 and various other electrical standards that we have throughout ElectricalOM. So some of the things that we're going to go through today on today's webinar, when I hand over to Dimitri, we're going to go through a lot of the basics really, in terms of how to get a project started, where we start creating circuits, assigning cable sizes, and what we can do with those designs. We will take a little bit of a look at the selectivity study, formerly known as, to many as, discrimination, as well as then looking at some of the CAD features that are included within our schematics and what we can use in there to improve our output for the client, as well as then creating things like cable schedules. And we'll look at some of the applications where we can apply certain situations for domestic, as well as more complex systems in the commercial system as well, using the same sorts of tools. We are planning some future webinars as well after this one. So we'll be taking a deeper look at some of the more intricates to do with ElectricalOM. So looking at some of the functionality where you've got huge numbers of circuits and you need to do mass changes. We'll take a look at using advanced modeling concepts within ElectricalOM, where we use our busbar trunking systems. We have UPS systems, power factor correction, automatic transfer switches, how we can couple and use multiple sources. So if we have generators in our systems, if we have additional supplies from the network supplier, or even a number of privately owned transformers on site, then we can bring all that data into ElectricalOM and run calculations based upon it. We'll also be looking the future towards our CAD plan design, so we can bring in drawings from various locations and architects, and we can add in our own electrical layers. It will also help with the scaling of the drawing, allows us to take data directly from those drawings, so it will automatically calculate things like cable lengths within your design. We also have our UK forms, which allows us to currently produce electrical installation certificates, electrical installation condition reports, and minor installation work certificates. We also then have that linked in with our mobile app for producing wholesale data in order to keep that system maintained throughout its life. We recently also released our arc flash calculation information, so we can now do arc flash studies within ElectricalOM. We have our Rivet on our Rivet system, where we can synchronize with Rivet to bring in entities from Rivet to create schematics, improve the design, and then put data back into Revit in order for us to create and fulfill those BIM requirements within that software. We also have various import and export functionality. We can import and export from various different CAD programs, as well as other types of certification and design software, being able to bring in and export out from legacy systems in order to bring those designs up to date. We'll also be looking at some of the content and feedback that you guys might give us today. And as we go through from the future, we'll hopefully be building some of our webinars based upon that feedback and the things that you really want to see from the software. We're always developing ElectricalOM, making it better, keeping with this improvement. And a lot of the improvements that we make to ElectricalOM come from our users. So where we have various core functionality that people want to see, such things that we've integrated already, such as lighting column designs, as well as transfer switch systems, UPSs, transformers, all of this comes from feedback from our client base. So we always encourage you to come back with any information or anything that you wish to see in the software, so we can look to implement that. We're always extending and adding to our protected device database. We've been working with a large number of manufacturers very recently. We're going to be seeing some live feed data starting to come directly into ElectricalOM. So the latest devices from various manufacturers will be available in our libraries. We'll be looking at the integration of other British standards. We have got a number of other standards already within the software. 5819 relates to fire alarm systems, particularly systems where particular lengths of cable may be under heat stress in the event of a fire, and calculating for certain areas of cable which may have a larger volt drop in these situations. We're always improving our BIM compatibility. We have our own plugin within BIM because we're an Autodesk developer. So we have various features that allow you to automatically wire and put wiring along containment routes and these sorts of things within Revit. We're also going to be looking at adding an energy efficiency module at some point in the future, where you can look at the energy efficiency of the system and assess how efficient that is. As well as we're looking to add and improve our certification database, so we're able to produce more certificates within ElectricalOM. So as far as just sort of talking about ElectricalOM, I'm going to leave that there now. We're going to kick into ElectricalOM with Dimitri. He's going to start going through some of the features there that we discussed earlier. And I hope you all enjoy today. If you have any questions as we're going along, please feel free to drop them in the chat. Some of them I will shout out and get Dimitri to answer as we're moving through things. Others I'll try to answer in the background via the chat as we go along. And I hope you all enjoy the next 45 minutes of webinar. Thank you. Dimitri?
Yep, thanks, Spencer. Nice talking. And welcome, everybody. Thank you for joining with us today. And we're going to cover some of the basics, of course, in this webinar. And as Spencer showed you in the PowerPoint presentation, we're going to cover more stuff in the future, just to try, keep you up to date with what ElectricalOM can do to help you with your electrical design. So what you see here, I know some of you guys joined today are comfortable with the environment and you know what software can do, but some other guys are not really aware of the system. So I'm gonna go through the very basics just to introduce the software to all of you, and of course to refresh some of the new features that you might see during this basic introduction. Of course, what you see at the very first screen is the main screen with the schematic area and the various other tabs, which we're going to cover in future webinars as well. So the way you start a project in ElectricalOM is by defining the main source. So this is the first thing that you need to do, and all the input that is done is through the input menu, which can be accessed through a right click. So that's the main thing that you need to know at the very beginning. You need to use your right mouse click to start inputting the components of the installation. And of course, the very first component, as I said earlier, is the source. So I'm going to start with a really basic example of a domestic installation, just to see how things are going. And then we're going to cover more advanced features like commercial installation. In this example, I'm going to right-click source and then choose a single phase one. All right, and then you see the component here. So this is the single phase source, and at the same time, you see the same component in this area, which is a tree network view, where you can quickly navigate through the network without the need to be on the schematic area. Okay, so if you on selectivity study, for example, you can just jump quickly to a circuit by just selecting it from here rather than selecting it through the schematic area. And to edit a component, you just need to double click on it to access the editor area of that component, where you can define various parameters. So this is the main source. So we're talking about all the factors that exist at the very origin point of the installation. And usually what we really need to consider here is the earthing system of the arrangement, the voltage drop limits that we want to cover, and the fault levels, and of course, external impedance. So this is the main stuff that we need to consider here. Of course, we try to make things with as much detail as possible, so that so we included some extra, features here, like the calculate fault power factor, which eventually is going to give you more precise figures for the RNX component of your impedance. And of course, this follows the international guides from the standards that most of the manufacturers are using to, test their equipment. So we are referencing the same standards that the manufacturers are using. So we are dealing with the same stuff. So the calculations, behave and similarly to what they are expected to be. So in that sense, we can quickly estimate that through defining the rating of the source. Okay, this is a user-defined source, and clicking the calculate fault level. Okay, and of course, calculate the power factor to change that. Or we can just choose another source type, like a transformer or a generator. Okay, so you can do these things from here. We have also some specific source types from the literature where you can predefine the rating of your source through this selection, and by choosing the relevant cable types and length, it will give you the prospective fault level at the origin point. Okay, so some parameters here to consider. Of course, you can manually enter the external impedance value based on what you believe should be the right one, and then fix the RNX component like that. Then you can go and define the earthing arrangement at the main earthing conductor here. So we're talking about the main earthing conductor here, which you can choose to use and define the main earthing arrangement and the size of this conductor. At this point, the software is performing some background calculations based on what exists in the installation. So you will notice that it will flag up errors while you will changing values, and this behaves interactively, explaining what's going on with any change. So I'm going to leave that there. In the premises diversity tab, you can define the premises type, which eventually is going to help you with your diversity factors calculation when you're doing your maximum demand analysis. Maximum touch voltage limits, 50 the usual case, 25 special location case. And in the others tab, we have some specific settings to be defined if you're aware of the DNO protected device or the distributor side, what is going to be the protected device there, and of course the tails conductor. So in this case, I will go with a typical arrangement we can find in a domestic premises, like using a fuse, 100 amperes of that particular fuse, and then choose to use a tails conductor. Before going to use that, I'm just going to go back to change, just to show you some of these values are highlighted with red. So what this red means is that this component, this protected device, is not sufficient to withstand the fault level that we have described at the source properties. So if I select that device, the error is going to flag up telling me that the ultimate breaking capacity of this fuse is not enough to withstand the fault level that we have specified here at the origin point. Okay, so this is something which the software, as I said, is doing all the time when you're selecting and changing values. So I'm going to go back to the 1361 fuse type 2, and then choose to use a tails conductor. And then you see again the warning message telling me that this cable that is selected right now is not correctly sized. And the reason for that is because of the current capacity of this cable, which is less than the rating of the fuse. So in ElectricalOM, we're trying to give you as much details as possible to help you with your selection. The software will never pick a value for you. It will never select something for you. You're responsible for the selection, but the software will guide you and give you enough information to help you with that particular selection. So in that case, I'm going to go with a larger cable size, which usually is 25 square meters cable size, to see that this can withstand this rating, and then everything looks okay. So before accepting the changes, I'm going to just check some extra symbols to be applied on the schematic diagram, where those symbols will be shown after the source symbol. All right, so after doing that, we can continue inserting the main consumer unit of the domestic installation. And this is done the same way like before with the right click. So we right click, and when we choose insert, and we see that other components are available for us to go and pick. So I'm gonna go with a distribution board here, single phase one. So this is my distribution board, which eventually what I want is to convert it to a split board, a dual split consumer unit, okay? So to do this, we need to change the typical ways of 4, the standard ways of 4 to 2, because I want from each way to insert an extension board, which is going to cover one section of the consumer unit. So I'm right-clicking again on the first way, insert extension board, single phase. And here we have the first split section. So we can change the ways again from here. So let's assume here we have 6 ways. We can change the RCD of this by right-clicking and edit it to an 80 amps or 100 amps RCD. Okay, and then we can continue by copying that and pasting it to the second way to form the rest of the part of the consumer unit. So in the case that we're gonna need less ways, we can just reduce the ways from here. Okay, so this is how we model a quickly domestic consumer unit here. So one thing that you might notice is that you get the tails conductors, of course, that we have defined in the source editor. After that, you get a protected device, a cable, an in-camera device, and the actual panel. But in our case, we would like that tails conductor to be directly connected to this board through an in-camera device, which is the main switch. So what you see here is a standard behavior of the software. So anytime you're inserting a component, it's going to come with a protected device, a cable, and maybe an in-camera device. In order to edit this arrangement, you need to access the source, the circuit editor. So by double-clicking on that, I'm going to access the circuit editor, where I'm able to define how this is going to behave. So in my case, I don't want to use any cable, so I'm going to uncheck the use conductor. Also, I don't want to use any protected device. I'm going to go to the protected device tab and choose not to use any protected device. Then I'm going to go to my in-camera disconnection and isolation, which is the in-camera side of my consumer unit, and change that to an AC22 disconnector with 125 amps rating. And I'm going to apply the changes. So go back to schematic now. You can see that the schematic has been updated with without showing any protected device after the tails conductor and any other cable after that. So this is what we need here. Okay, so this is what we're expecting our main consumer unit to be. And then we can start inserting some final loads. So let's pick a way here double click on that, and then it's going to give us access to the circuit editor of the first way of the first section. Okay, so here we're going to just type some description. So let's assume this is a lighting circuit. From here you can choose the type of the circuit that you would like to model. So I'm going to choose lighting. Here you can define the number of lighting points you have in that particular circuit, how many watts you are assuming this lighting circuit is going to consume. So depending on the case, you may leave it 100, which is the worst case scenario, or you may go with a smaller value if you're going to deal with some more efficient lighting equipment. And then this is going to work out your design current. Okay, so as I said, we are trying to give you as much details as possible, as much information as possible to help you with your sizing. So that's why we have this dashboard, let's say, of this circuit editor, which is explaining what's going on at that particular moment with this particular selection. So other stuff that you might see in these error messages are related to the installation method, which might not be really critical, but it's good to make sure that you're going to comply with all these regulations, which you have to comply when describing any this kind of installation, which involves cables in walls, for example. So in my case here, I don't want to use a single cord cable installed in a conduit in a wall, but I would like to use a flat twin and earth cable. Okay, so what I'm going to do, I'll try to pick one from the phase and neutral conductor list. You can see that that list is quite extensive, so it's kind of difficult for us to pick one value. Of course, if you are familiar with that list, it's going to be quite easy, but the first time it's going to be not so easy. So it's good to use that filtering list which we provide. So we can choose, for example, the insulation material and if it's going to be armor, non-armor. And then you can see that this list filters with those selections. And now we can pick easily the right cable type. Okay, so this is the one I would like to use. And then we need to choose the right installation method. So I will leave it on space clip direct. Then the length of the run. Okay, so let's assume 25 meters. And then the size of the cable. Okay, I would choose 1.5 for this case. If I leave it to 1, that's fine, since it's covering all this, it's complying with all the calculations that need to be cover all these inequalities. But some cases you may want to choose a larger cable size. At this point, you may see some extra details related to the current state of this selection, and here you see the full loaded temperature of this cable and the actual temperature when it's under use. So here, of course, the other correction factors are listed, which you can go and correct from the correction factors tab here. Okay, so before doing that, I'm just going to navigate quickly to the earthing tab here to show you how it's dealing with the earthing conductor. And because this is a flat twin and earth cable, the earthing conductor is integrated into that cable. So the software will use that standard. Then we go to protected device tab, where we can choose the right protected device. So in this case, we have an MCB device, 10 kA breaking capacity, type C, 6 amperes. And we can change it.
What we've just done this particular one, Trevor Cole posted up a question. He was having an issue where his devices are KA, and software is popping up a warning around the breaking capacity with the 6 kA. So I was just hoping while we're here and we're looking at this, if we can show him why that's happening in terms of the supply data, and then obviously with the breaking capacity that's been selected on the
yeah, definitely. So at this point, the software will give you a list of devices which are are okay to be used in terms of the breaking capacity checks. As I said, it's going to mark them with red. So you see all of them are okay to be used. And the reason why is because of the fault level at the origin point here, which is 1.5. Okay, so in Trevor's case, that fault level, I guess, is going to be more than 6. All right, so that's why it's going to provide that that error message. So if I turn that, if I apply this change, go back to supply side and change that to, let's say, 7.5, and hit OK, then choosing a 6KA MCB here is going to flag the error. Okay, and the reason for that is because of this fault level, which is higher than the breaking capacity of that device. Okay, so we need to make sure that we have defined the right details at the supply point. And in other cases, we have current limiting devices, which eventually is going to limit the fault level at the downstream side of the circuit that is under study. And eventually it's going to allow us to use a small breaking capacity for that particular device following the backup protection scheme or cascading scheme from the manufacturer's data. Okay, but in order to achieve this kind of behavior, we need to choose manufacturer-specific devices. Okay, so if I choose, for example, here a Schneider device, let's choose this this MCB. Let's go to something like that. You may see this extra checkbox where it's telling you that this device is capable to limit the fault level. But it's not going to do anything for us right now because the fault level already, is coming directly from the upstream side. So we need to use an upstream limited device to help us with this particular case. Since we're not using any limited device at this particular case, there's no limited device used. The fault level that's going to eventually end up here is going to be 7 point something. 7.3. Okay, so that's what's going on here, and that's why you see this behavior. Let me check some other options here, which, yeah, okay. So I'm just checking some default options here, which might affect the fault level calculations. Since we are here, I have accessed this from Edit, Project Info and Options, Cables and Checks, where you can predefine the behavior of the software in terms of some specific calculations where it's doing in ring socket circuits, for example, if you want to do backup protection, discrimination study with the backup protection from supplier, some fault level calculations related to the international standard, some behavior related to the fuse sizing and cable sizing involving fuses, GG fuses and this is coming from the international standard as well. So we're including extra standards that enhance the whole, study based on what the designer would like to, to incorporate in his studies. So this is not part of the BS, by the way. We included that due to some, requirements from international companies. So you don't have to use it if you're dealing with British standards. So you just uncheck that option. And of course, here we have this current limiting effect, which is always enabled when you're having a current limiting device, which is good to have since this is going to be the exact behavior of that device. So let me go back and change that to a more appropriate device since we have 7.5 Ka. I'm going to choose something like that, which is a 10. Yep. Okay, that will do the job. Oh. Yep, correct. So I'm going to apply that, and let's go back to schematic to see what's going on. So here we have that MCB, 6 amperes, 10 Ka. Here we have the cable type that was selected, and here we have the final load. Okay, so this is a way you describing a circuit. Now, if we want to replicate that and copy it, we can just right-click and use copy, and then we can right-click and use paste. Okay, now it's replicating the whole thing. Then we can just go here and maybe change some of the description or some of the other, stuff about the points. But most of the stuff will be the same since we're talking about the same, circuit kind. Now let's insert a ring main circuit. So I'm going to double click there. I'm going to choose switch socket outlet ring, define the number of points. Let's say 10 again. Watts of a point, 200, and then we get the design current. So in some cases, you may want to define here, instead of this multiplication of 200 watts per 10, a value which eventually is going to be your maximum design current, which you want to cover. So in that case, you might check this total load box and define the load or the amperes you believe should be the maximum to consider here. Okay, so this is not gonna do this 10 times 20. It's just gonna use the 20 amperes as your design current. Okay, so that's why we have this tick box there to define the loads that you believe should be the design current of that particular circuit. And then we can go and choose the right cable type. So I'm going to stick with the flat twin and earth cable type. Oops. Okay, you see here we are populating the standard, so or the table from the from BS, the conductor material and the description of the cable. And in some other cases, you might see, for example, if I choose an armor cable, you may see that this is a steel wire armor cable, and you may get extra options for this particular cable. For example, if it's a fireproof cable, if it's low smoke and fume, zero halogen, or if you want this to be round to 70 degrees, since this is a 90 degrees rated cable. So all these, which are all these options, which some of them are listed in the regulation, are supported here to help you with your designing aspects. So let me go back to flat twin and earth. I'm going to choose a directing wall ceiling. I'm going to choose this installation method. I would like to comply with this particular installation criteria, and then choose the right size. So now you see extra arrows and plugs here. So this is about the ring circuit, and since we have a requirement to use at least 2.5 square meters cable, this is flagged by the software. So we need to go with 2.5. And you see that after choosing 2.5, some other warnings are also eliminated. This is the actual temperature, which is higher than the full loaded temperature. So if we go with 2.5, this is reduced to 66, which is less than 70. And then we're going to choose the earthing tab, which is fine. Protected device, still, this is a ring circuit. We have a requirement for 30 or 32 amperes of rating of the protected device. I'm going to change that, still with Schneider, and then choose a particular device, something like that, and 32. And then you see that all the warnings are eliminated, meaning that this is a acceptable behavior. Now, one thing here to consider is the limits here. So the minimum current capacity in this case is 20 amps. In our case, is 21 what we selected. So the current capacity of this particular cable is 20 amps based on the installation method. So we're quite close to the limit. So in some cases where a grouping factor might be applied, or ambient temperature factor or insulation factor might be applied, this is going to cause problem. And let's go and check that. So if we go to the correction factors tab, and let's assume we're going to have 2 or 3 circuits grouped together, okay, you see that we're going to get a warning about the current capacity of this particular cable. In this case, it's going to cause us to choose a larger cable size. Okay, so all this is directly changed based on what the consideration with the grouping factors are applied here. The same stands with the ambient temperature and so on. So it's good to consider the grouping factor as well when you're dealing with this cable sizing environment. Of course, there are special cases where if you space the cables, you don't have to consider the grouping factors, or you have to consider, the most loaded cables to be included in that particular grouping factor arrangement. So stuff that you might want to consider before choosing this number. And we're planning to develop something more extensive in that particular case, where you're going to define groups of circuits, and it's going to cover all the aspects of that grouping behavior and containment behavior, how things are included in that containment, for example. But this is for the future development. So I'm going to apply that, go back to schematic, we get this socket circuit, which I'm going to quickly copy and paste there. Okay, so I'm going to leave that there because I want to spend some more time with the commercial installation. Before closing this, I'm going to show you how you can quickly print it. You can include a frame here. You can access the drawing mode, where you have the ability to insert symbol legends, which is going to list all the symbols for you. And we have other features here. You can use the drawing mode features, like, consumer unit. So we're going to cover those features in more depth in other webinars. So I'm going to just go through them quickly. So in this case, I would like to move this a little bit so it will not cover my consumer unit. And this is ready for printing. So if I click print, you can print that like that. You can export it even to PDF and share it, or you can export that to a DWG drawing to use in CAD software. So let me now go to, let me close that. Unless you have something to ask. So Marcus,
I'm busy, sorry, I'm busy tapping away in the background with quite a few questions popping up.
Yeah.
But yeah, I mean, we have here, I've had a fair few questions from people about defaulting the different types of MCB.
Yeah.
Now, in software, we can automatically, you can set your own minimum values for things such as cable sizes and also certain symbols, which is for another webinar. But at the moment, in terms of default protected devices, there isn't a feature there where you can select a particular circuit and say you always want that particular device of that particular type or current rating to be applied. But it is something we could possibly look into as something else. Dimitri can just show you quickly on the screen where you can input your own minimum cable sizes to pop up for certain loads. But that is the way that is.
So if I can just add something here, we are planning to develop a templating system where you can define, predefine, let's say, properties for each type of circuit. For example, for sockets, you like this kind of this type of MCB, this type, or this particular protected device, this range, this manufacturer, this cable size. So you can predefine them and save them as a template. So you don't have to, repeat the process all the time. Just choose a template. It's going to initialize that for you, and then if you want to make a change, you can quickly do it. So we're not individually doing defaults because we're planning to develop this templating feature, which eventually is going to cover all these cases, right? So it's something which is under development. It's going to be available on not in this release, which we have just released, but on the next release planning in 2 or 3 months. So it's going to cover all these, defaults that you like to see in your circuits.
Just one other question here, I think, from Mark Abbott. I can't seem to find any AWA 90-degree rated tail conductors from supply. I'm guessing that the CU in the material.
Yes, so the list from the tails conductor is quite limited, and we still that limited because we want you to go through the circuit editor where you can see more details there. We have this tails list So if someone is not following, we're talking about this list here, which is limited. So in that case, where you have a tails conductor, which we'd like to define with that particular cable type, and probably with other installation methods and considerations, it's good to skip that from here and do this from the through the circuit editor. So you can have a connection point that will eventually is going to be a junction box, for example, which is going to describe the first section, the cable section, which is the tails conductor, and this is a fuse from the DNO protected device. And from here, you can do whatever you want. We have an extensive list of cables you can choose, and I guess you are talking about which is the one? I guess is this one. So, and because here we have all these options, which eventually you would like to choose, which is going to affect your calculations. So if it's something more specific or more, let's say commercial based, we encourage you to use the circuit editor rather than choosing the tails conductor from the supply side. Okay. So I will do that. I will just change the protected device here to something like, so I'm going to start modeling a commercial situation here. I'm going to choose an NSX device here, something like that. Just another thing to notice here is when you're defining a device which accepts settings, that has adjustable settings, those settings can be defined directly through the protected device selector. Okay, so you can adjust, for example, the overload rating of that setting directly from here, of that device from here, or other settings like the instantaneous pickup from here as well, and other settings that are provided. Okay, of course, more extensive illustration of those settings can be seen in the selectivity study, which I'm gonna cover in a few moments. Let me go and size this correctly. So I'm gonna go with the 95 degrees, size of this particular cable. This aluminum wire armor, so I'm gonna stick with that, apply the changes, go back to my schematic. So I'm gonna rename that to, let's say, main connection or something. And then I'm gonna add my main switchboard. So another cable with a protected device to the switchboard, or we can just get rid of that with right click and delete. So we just have the cable there. Or if there's no cable, we can just directly insert that as a switchboard instead of a connection box. But in this case, I'm assuming there is another cable, maybe changing the installation method. So let's assume this is installed in ground, which I guess that should be the usual case. And then our main switchboard will be of the same cable type, but instead of installing ground, it will be clip direct. So from ground, we're going to clip direct method to end up to the main switchboard. And then let's assume 5 meters there. So here you can see that we haven't defined any protected device, and the software is looking upstream to get the protected device used, which is going to be the one we need to use for sizing this particular cable. So you see exactly the same device for this case as well. So I'm going to apply this, and then this is the main switchboard. And from here, we can start inserting sub-mains. So I'm going to right-click, insert distribution board, 3-phase. Okay, so I'm going to do a couple of them just to show you how the software behaves in rearranging the network. So you see that the software is putting things around and is layouting the network in the sense that no overlaps are going to be applied. So this is something which you may have when you move things around, but you can auto layout that, like with this option here, and it will refresh them and put them in the right place so there's no overlapping. And of course, you follow exactly the same process editing each of these components. So another thing that we recently developed is the multi-selection which you can multi-select things and then delete them. Just press the delete button, by the way. And I'm just going to show you how you can quickly insert circuits so you can really optimize the workflow here. So I'm going to insert a final load here. I'm not going to bother defining them. I'm just going to show you, let's assume we have this. And then you can stick in this area without going back to the schematic. So you can stick in this tree network view and double clicking on each circuit and start editing it. So you don't have to go back to schematic, select the way, maybe right click and insert whatever you want. It's going to be a single phase final load. You just double click, it's going to take you there, and then you can stick in this particular area and then continue, right? So it will optimize the workflow. Now, in any case that you may have a submain, you can of course go back to schematic and right click on the way you like to install that submain, like that. Okay, or you can even do that directly from here. So you can right click, insert distribution board, single phase. Okay, so by staying here, it's quite easy and efficient way to model the network without looking at the schematic. Because eventually the schematic is gonna auto layout itself. It's gonna show you exactly how it's gonna look like. So if I start inserting circuits here and just copying and pasting, eventually you're gonna see that the schematic will be auto layouted without even being in the schematic tab. So you see everything is here. All right. So that's just a way to optimize the workflow. Another thing that I would like to show you here is how you can quickly insert various other components. So in this particular case, I would like this to be another style. Let's assume a vertical arrangement of a distribution board like that, or maybe like that. So this is going to be auto layouted again to apply all these changes. So we see this layout like that, and we can change the way numbers from here as well. Now, see everything is rearranged based on the way numbers and the ways location. Now, let's assume that, let me collapse them. So let's assume that I have forgotten to insert something at the very first way of this distribution board. Okay, so how are we going to deal with that? We don't have to cut and paste to move things around. We just use the right click, shift down functionality or shift up, depending on the case. So now it's going to give you this extra way to enable you to add the anything that you missed at the very first way, maybe another submain. Okay, so using the shifting up and down functionality can be an easy way to rearrange the network, or you can also drag and drop things around. Okay, so you can drag drop things, move them or replace and keep them. So you can adjust what this panel should have. Now, let's assume this is a multi-story building and we have similar arrangement in each floor. So this might be the ground floor or the first floor. We can just copy that. And when we're copying something like a distribution arrangement, it's going to eventually cover the whole downstream part of the network. So you see the whole downstream part is copied as well. And then you can go in each component that is different than before and then change it. So you don't have to replicate the whole thing from scratch. So let me just quickly add another one. Okay. So now we have something like that, which looks quite complicated. So in order to make things easier, you might want to move these guys to another page. So you can select them all, right click, schematic functions, and create page. So now what the software will do will create new pages for each of these submains. So instead of having them next to each panel, it's going to take them to another page where you can continue working in that particular panel. And you can, of course, show it separately like that. And you can see the pages from here, okay? So this is the pages that we just created. Another thing that you can do, you can select those and tell them to be in a compacted mode. So what the compacted mode will do, it will hide all the final loads and just keep the symbol of distribution board there. Okay, so all the ways are hidden. It's much easier for someone to look something like that. Right, so all these features are available and just something which you need to kind of go and explore to see the behavior and see what these things can do. Another thing is that you can untether them. So if I right click, schematic functions, untether them. So you can move them on the side. So still you have them like that with a placeholder, but you have them in the same page and you can rearrange them like that if you want. Okay. So there's various features you can use to actually describe how your stuff will look like. Now, let's assume that I would like to show next to each main panel here a cable schedule that lists all these various cables. So I can select this panel and go to this cable schedules function, and it's going to list for me all these cables connected to that particular panel. And now in this cable schedule dialog, you can choose which column you like to include. So we have many columns for you to include here, and we're always, improving that by adding extra columns based on what the user would like to have and to eventually populate here. And after doing that, you can refresh, and then you can insert that to your schematic. Okay, so here we have the panel here, and of course below that the cable schedule listing the details of that particular panel and what cables you have there, and some results like the voltage drops. Okay, so you can do this for any selection. Of course, here you can just list all the distribution circuits. So if you want to list only the distribution circuits within your project, you can just choose all distribution circuits, or if you want to list the whole thing, you can just do it like that. And we have the export to Excel functionality where you can export all this to Excel if you want to quickly share it or make some changes and share it with your colleagues or your clients. So this is how you can eventually customize a report of cable schedules by choosing the columns you like to include. Okay, refresh it, and then you can export it. So all these details will be exported so you can use them the way you want.
I've just had a question actually on this pop up by Richard McWilliam. He's asked, can you reorientate the cable schedule, say landscape to portrait, so that it can easily fit in written documents?
So we have a lot of ideas for the cable schedules. We haven't done that yet. It's something we're looking to do. What I think Richard is suggesting is if you like to list this schedule for a particular component of your arrangement. So for example, let's say I want to list the cable details or what's going on with this particular section. I would like to have them in another order. So eventually, instead of having them like that, horizontally, have them vertically arranged. So it's easy for me to place them here. So I guess this stands when you're dealing with a single circuit, which is a case for us to go and implement something which you have planned to implement to allow you to list something or any detail you want for this particular circuit through a functionality which we're going to implement. So from here, you will be able to right-click, for example, and say list results or list details, and then it's going to give you a box here of various details and results that you'd like to list. So I think this is what Richard is referring to. If I'm guessing, right?
I haven't seen anything else pop up from him as of yet.
Yeah. So,
but if there is anything there, Richard.
Yeah.
you've
Yeah,
got queries on, please pop up a question.
yeah. So the idea here is to enable you to choose what you like to list for each individual cable rather than for a schedule list. Okay, so eventually you can have this next to each, cable. Okay, so I think we're running out of time, but if there's something you'd like me to show, yeah, I think I forgot to show you the selectivity study, which is
I've
quite
got
important.
selectivity study. I mean, we can cover that in a future one. I mean, there's a few questions here.
Yeah.
Like knocked off. I mean, I'm busy. I've got quite a lot of questions popping up. So
Yeah. All right.
try and pop a
That's
few
good.
here while we have a little bit of time here.
Yeah.
So, one of the questions here is about renaming the ways that on the distribution. So we've got 1.1 L1, and you'd like to rename it to just 1.1. Now we do have some features, some functionality for renaming the ways. So if Dimitri, if you could just pop up the the information for changing the specification of where it says L1, L2, L3.
Yeah. So from edit project info and options, you can define from the design defaults how you'd like to list the prefix of your
It's
ways.
also good there that while we're there, I answered this question for somebody earlier. They were asking about the main supply orientation, so starting their supply at the bottom or at the top. And here we also have where we can set the default for that, where we want it to start from. So you can have your design start at the bottom of the page and work its way up, or you can have it from the top working its way down, or even from one side to the other. But also when you're in the schematic detail, we can take any part of that and we can actually rotate it while we're in the software. So there we go. So it's now flipped it the other way up, and we've got our supply there at the bottom.
Yeah, so you can apply transformations to any part of the network through the schematic function. So you can rotate left, right, mirror, of course, move things around.
Yeah, I think some of those are really for sort of a few future webinars we're planning on doing going forward anyhow. I've got another good question here about error alerts being more specific than just an exclamation mark. Well, just at the bottom of the screen, underneath the schematic there, you may notice that there's some information there. So every error and warning that is coming up is actually being populated down here with a bit more information about what is there. And also when we hover over any exclamation mark or any piece of data, it's going to give us information about what that exclamation mark is referring to. So it's always going to give you more information than just that red mark there. So
yeah, also it's going to give you some recommendation because the software knows what the factors are involved in this particular calculation. So it's going to give you some recommendations what you need to change or revise in that particular error message. So for example, this is revising the CPC or the protected device, because this adiabatic check is related to the CPC size, but also to the protected device, because it's going to cause the protected device selection might affect the disconnection time and eventually the time factor in this adiabatic check. So all these details are something which we can recommend you to do so, but of course there might be other factors, like for example the supply side, which you need to make sure that is correctly defined, or the main cable or the upstream cables. So all these details of course are going to affect your calculations, but yeah, you get some detailed messages which are trying to explain what's going on and what you need to consider to fix that error.
I've also had a few questions pop up about how this software is different from other softwares on the market. And there's a number of things that make us very, very different. I mean, later on in the webinars that we're planning for the future, you'll really see some of the big things, like various types of load and things that we can connect. So we've got on our schematic, sorry, Dimitri, I'm just going to take over for a second here. So where we've got our schematic here, and we come in here where we've got our various loads. We've got things like of various different connections. So we've got things like specifically designed systems for transfer switches, transformers, UPSs, which all contain very specific data that may relate to certain manufactured pieces of equipment like loads and those sorts of things. So it takes all of these sorts of things into account, as well as we've got our various other things that we're going to look at in the future, like the CAD plan design, being able to bring drawings directly into ElectricalOM and calculate circuit lengths and fault currents from scaled drawings, as well as in its essence, although ElectricalOM, like many other design softwares, is a calculation engine, ours is really based upon CAD principles, and those CAD principles allow us to do a great many things that a lot of other softwares out there can't do. I mean, from what you're seeing here on the schematic and what we're doing, I mean, we can bring in certification from our mobile app, and it will automatically populate this schematic and those sorts of detail and that information, which is something we'll be showing in a future webinar. I'm well aware that we're just a few minutes over at the moment, so thank you very much all for bearing with us.
Just know that we're gonna pick any questions that we haven't answered, and answer them and send them over to you, just to cover any missing points. But of course, as Spencer said, we're gonna continue doing webinars, so eventually we're gonna cover many of the stuff that might not be clear. Also, I've noticed some sales-related questions. The reason for doing this kind of webinars is not, to answer any sales-related questions. Those can be answered by just contacting us to our sales department. So we'll try to keep this in a technical level, trying to improve the knowledge using the software and what the software can do, and to cover any missing points that that are related to the functionality of the system, and of course get the feedback from you guys and improve the system.
There are a few questions here that have been about sort of feature requests. Yes. By all means, if you want to email us directly at support@modecsoft.com, put your feature requests down. We take all feature requests very seriously. Many of the features and things that we've got going in the software now, as I said earlier, come directly from customer feedback. We're very much of the mindset that we like to provide software that the industry needs, not provide software that we want the industry to use. So if you do have those sorts of things, send them over. We will be looking at all of them, and as we see trends in various features that get regularly requested, we do implement them quite quickly. So by all means, please do email us.
I just saw something from Mark. I don't know if I have some extra few minutes. So about the cable type that he was suggesting to include in the tails list. Yeah, I mean, if something is not part of the tails list, you don't have to insert the junction box. You just insert directly the switch port, and this part will be your tails. Okay, so you can include here your incomer. So this will be your tails conductor, and here you're going to have the fuse from the DNO.
We've also had a question from Alan asking when our next presentation will be. I believe we're penning these in for once a month. So as it stands. And if attendance is keeping up as high as it has been, I mean, this has been very well attended. We may look to doing more as well.
Yeah, depending on the let's say the demand, we might do 2 per month. We're gonna see. Yeah, we just have a plan for once per month, but I see that it's there's a lot of demand here, so we might consider doing 2 per month. We're gonna have to work it out.
Excellent. Well, I think we should call it time there. I mean, we've run over quite a bit from what we've said that we were going to do. I'd like to thank you all very, very much for attending. We'll make sure that any unanswered questions that haven't answered will be answered and sent back to you. And we will also make sure everyone gets an update on when the next webinar will be going ahead. As I said, we'll be going over different features next time. So we'll be looking at various other features around our circuit details tab, various things to do with our selectivity study, generating reports, and then some of the other more advanced types of connection and things that we can use on the system. But again, thank you very much all for attending. And that's all I have on there. Dimitri?
Yeah, thank you very much. And of course, I know it's difficult and tough time for everybody. So just stay safe, and I guess we're gonna see you in the next webinars.
Yeah. Thank you very much.
Thank you very much.